Poisson distribution. Poisson distribution is the discrete probability distribution of the number of events occurring in a given time period. In this case, the average number of occurrence of the event over that time period is known. It was developed by French mathematician Poisson in 1837. A random variable is said to have Poisson distribution if the following conditions are satisfied. Condition 1. The event can occur any number of times during a time period. For example, it's possible to have no occurrence of the event at a certain point of time, and the event can occur numerous times over the following period of time. Condition 2. The events occur independently. In other words, if an event occurs, it does not affect the probability of another event occurring in the same time period. Condition 3. The rate of occurrence is constant. That is, the rate of occurrence does not change based on time. Condition 4. The probability of an event occurring is proportional to the length of the time period. For example, it should be twice as likely for an event to occur in a 2-hour time period than it is for an event to occur in a 1-hour period. Now that we have discussed the conditions for a random variable to have Poisson distribution, we are ready to see the probability mass function for a Poisson random variable. Let's see. This is the Poisson distribution formula. It says that for any variable x, p of x equals e to the power minus lambda times lambda to the power x divided by x factorial. Here, x is the Poisson random variable and x can be equals to 0, 1, 2, 3, any number up to infinity, and x represents the number of occurrence of the event during the time interval. Lambda is the mean number of occurrences in the interval. And E is Euler's constant, which is approximately equal to 2.71828. It's an irrational number and very important, just like pi. So I repeat the formula. If the mean number of occurrences of an event in the interval is lambda, then the probability of x occurrences of the same event during the same interval is e to the power minus lambda times lambda to the power x over x factorial. Now there are some textbooks who use mu to interpret the mean number of occurrence of events instead of lambda. So their formula look like p of x equals x, e to the power minus mu, mu to the power x over x factorial. You can use either of the symbols in the formula while solving the problems. Now we're going to talk about how to use the Poisson distribution formula in order to solve problems. So take this problem for example. A small business receives, on average, 12 customers per day. What is the probability that the business will receive exactly 8 customers in one day? So the first thing you're going to keep in mind that the time interval is the same. So thus, the mean lambda equals to 12. So it's 12 customers per day, or the average is 12 customers per day. Now to calculate the probability, we're going to use the formula p of x equals lowercase of x. The small x in this case is 8. Because that's the probability that we're trying to calculate, we need to determine the probability that the business will receive exactly 8 customers in one day. So x is 8, and the formula is e to the minus lambda, lambda to the x, divided by x factorial. So let's replace lowercase x with 8. So this is going to be 12 raised to the 8 times e to the negative 12 divided by 8 factorial. So if you plug this into your calculator, you should get 0.065523, which if we multiply that by 100%, that's approximately 6.55%. So that's the probability that the business will receive exactly 8 customers in one day. Number 2. A student receives, on average, 7 text messages in a 2-hour period. What is the probability that the student will receive exactly 9 text messages in a 2 hours period? So what do you think we have to do in order to solve this problem? Would you like to give it a try? You can pause the video and try to solve it by yourself. Now, there's something that you need to pay attention to. It's the time interval. Notice that the time interval doesn't change. It's the same. Therefore, 7 is the mean. So lambda equals to 7. Now, the only other thing that we need to find is x. We can clearly see that x is 9 because we want to calculate the probability that the student will receive exactly 9 text messages in a 2-hour period. Now we need to calculate p, where x equals to 9. So let's go ahead and plug everything in. Let me write the formula here again. E to the minus lambda, lambda to the x over x factorial. Now lambda equals 7, x equals 9. So putting the values of lambda and x in the formula, we get that p of 9 equals to 7 to the power 9 times e to the power minus 7 divided by 9 factorial. Let's type it in the calculator, and the value we get is 0.1014, which correlates to approximately 10.14%. Let's move on to part B. What is the probability that the student will receive exactly 24 text messages in an 8-hour period? So notice this time, the time period is different. Therefore, the mean is going to change. The mean was 7 when the time period, let's say T1, was 2 hours. What is the new mean value when the time period is 8 hours? So by looking at these values, you can see what it is. To go from 2 to 8, you need to multiply 2 by 4. Therefore, you need to multiply the mean here by 4 to get lambda 2, which is 28. 7 times 4 is 28. So that's the new mean value. Now let's rewrite what we know. So lambda equals to 28 for problem B, and x has to be 24, right? Because you want to calculate the probability that the student will receive exactly 24 text messages in an 8-hour period. So x is 24. Now p of x equals 24. That's going to be lambda to the x, which is 28 to the 24 times e to the minus 28 by 24 factorial. Now working this out in the calculator, we get 0.060095. So multiplying it by 100, we get it's approximately 6.01%. So that's it for question 2. Number 3. A small business receives, on average, 8 calls per hour. A. What is the probability that it will receive 7 calls in an hour? So now we know how to solve this type of problems. So we can clearly see that the mean is 8 and x is 7. Since we're going to calculate the probability that it will receive 7 calls in an hour, so it's going to be p of x equals to 7. So that's going to be e to the minus lambda, which is e to the minus 8 times lambda to the x, 8 to the 7 over 7 factorial. If we plug this in, this is going to be 0.1395865, or we can say approximately 13.96%. So that's the answer for part A. Now let's move on to part B. What is the probability that business will receive at most 5 calls in an hour? Now lambda is still 8, that's not gonna change. What is x? X could be any number, any whole number up to 5. So we want to find the probability that x is less or equals to 5. So this is going to be equal to p of x equals to 0 plus p of x equals 1 all the way up to p of x equals to 5. So we have to add up the individual probability values. Now fortunately there is a quick way of doing this. I'm going to rewrite the formula to show you. So it's lambda to the x e to the negative lambda over x factorial. Now x is the variable. Lambda and e doesn't change. So what I'm going to do is I'm going to factor out e raised to the negative lambda and then write lambda to the x over x factorial, because that's the part of the equation that will change with the change of the values of x. So it's e to the minus lambda that's it. So we can say that p when x is less than or equals to 5 is going to be e to the negative 8 times, and then we're going to plug in the values of x from 0 to 5. So 8 to the power 0 by 0 factorial, 8 to the 1 by 1 factorial, all the way up to 8 to the 5 by 5 factorial. Now go ahead and type this in your calculator. So I got 0.191236, which is approximately equals to 19.12% chance. So this is the probability that the business will receive at most 5 calls, yes, in an hour. So that's it for part B. Let's move on to part C. What is the probability that the business will receive more than 6 calls in an hour? So the time interval is still 1 hour, therefore lambda equals 8. Now we want to calculate the probability that x is greater than 6 but not equals to 6. So x could be 7, 8, 9, 10 and so forth. Now this can go to infinity, so it doesn't end. How can we find the answer in this case? Well, let's draw a picture. The Poisson distribution has a graph that is decreasing over time. The probability is on the y-axis, the random variable x is on the x-axis or the horizontal axis. Now let's say x is 6 at this point, so we're going to split the graph into 2 parts. Now let's say the probability that the business will receive 6 or less calls is 30%. Just to give a number for the sake of illustration, what is the probability that x will be greater than 6? Right? The total area under the curve, which represents the total probability, is 1 or 100%. So if the probability for x less or equals to 6 is 30%, then the probability that x is greater than 6 is 100% minus 30, which is 70%, because these two have to add up to 100%. So on the left side, this represents the probability that x is less than or equals to 6. On the right side, this represents the probability that x is greater than 6. Now if we add these values, this is going to be equal to 1. So if we take this term and move it to this side, we can say that the probability that x is greater than 6 equals to 1 minus the probability that x is less or equals to 6. So this is going to be equal 1 minus the probability of x equals 0 plus p of 1, p of 2, up to p of 6, right? So again, it's 1 minus e to the negative 8, which represents e to the negative lambda, times summation of lambda to the x by x factorial, where x is equals to 0 to 6, right? So it's 1 minus e to the minus 8, 8 to the 0 by 0 factorial, plus 8 to the 1 by 1 factorial, plus 8 squared by 2 factorial, up to 8 to the 6 by 6 factorial. So I got 0.686626. It's approximately 68.66%. So it's 68.66% chance that the business will receive more than 6 calls in 1 hour. So the chance is high, and that makes sense because the average is 8, right? So that's it for your Poisson distribution lecture. Hope you understood it well.